All right, today we're going to take a journey from the just mind-boggling scale of the cosmos all the way down to the mysterious forces that actually run the whole show. We're drawing from the work of Dr. Mostafa Mahmoud, and we're going to explore the universe itself and see how science and faith can sometimes end up asking the exact same questions. So here's the game plan. First, we're going to try to wrap our heads around the sheer size of the universe. Then, we'll get into the great puzzle of gravity, see what happens when stars reach the end of their lives, and explore this really fascinating place where science and faith meet. And finally, we'll look at what it all means for where we're headed. Okay, so before we can even begin to talk about the forces that shape our reality, we have to appreciate the stage they're playing on, and let me tell you, it is bigger than you can possibly imagine. See that number on your screen? That's our best guess for the width of the known universe, in kilometers. It's got 25 zeros. I mean, it's a number so huge our brains literally aren't built to understand its scale. We're not just talking big. This is a completely different kind of existence. So that leads to the big question, right? What is the invisible glue holding all of this together? What's keeping galaxies from just flying apart into the void? Well, the answer is a force that's absolutely everywhere. And as we're about to see, it's also deeply, deeply weird. And that force, of course, is gravity. It's the grand architect of the cosmos. It sculpts galaxies, it dictates how stars move, and yet, on a smaller scale, it's unbelievably weak, and it's full of contradictions that have had scientists scratching their heads for centuries. And here's the central paradox. On one hand, you've got gravity, the master of the entire universe, running the cosmic dance. But then you zoom all the way into the level of atoms, and the force that holds a nucleus together is just ridiculously stronger. It's a real tale of two extremes. And just look at how massive that difference is. The force inside an atom is stronger than gravity by a number with 36 zeros. Think about it. Gravity holds an entire galaxy together, but you can pick up a paper clip with a tiny refrigerator magnet completely overpowering the gravitational pull of the entire planet Earth. That's the puzzle we're up against. So how did we even get a handle on this bizarre force? Well, it wasn't one single aha moment. It was more like this incredible relay race of brilliant minds passing the torch of knowledge from one century to the next. You can literally watch a revolution in human thought unfold on this timeline. We went from thinking Earth was the center of everything, with planets moving in these perfect heavenly circles, to realizing the sun was the center, to discovering the paths weren't circles at all but ovals, and then came the heavy hitters. Newton, who gave us the how, and Einstein, who gave us the truly mind-bending why. What Newton did was just genius. He came up with this beautiful, elegant mathematical formula that could predict everything from the ocean tides to the path of a cannonball. He basically wrote the rule book for how gravity works. But even he had to admit he had no idea why it worked. The fundamental cause was still a total mystery. And then Albert Einstein just flipped the whole chessboard over. He suggested that gravity isn't some spooky force pulling things. No, he said that massive objects like our sun literally bend and warp the fabric of space and time around them. So planets aren't being pulled. They're just rolling along the curves in space-time, like a marble on a trampoline. Now, this idea of gravity being so powerful it can bend the universe itself, well, that leads us to some of the most extreme places in the entire cosmos. So let's see what happens when gravity finally and totally wins the battle at the end of a star's life. A star's destiny, it turns out, is all about its mass. A star about the size of our sun will eventually fizzle out and shrink into what's called a white dwarf. A bigger star collapses even further into a ridiculously dense object called a neutron star. But for the real heavyweights of the universe, gravity's victory is absolute. They collapse into a black hole. And this isn't just an object. It's a breakdown of reality itself. The curve in space-time becomes so steep that nothing, not a planet, not a star, not even light, can climb out. It's a point where time itself grinds to a halt, and all the laws of physics we know just fall apart. It is the ultimate cosmic dead end. So, right here at the very edge of what physics can tell us, Dr. Mahmoud's analysis takes this really fascinating turn. The source material starts building a bridge between these modern scientific discoveries and verses from the Quran, suggesting they might be talking about the same cosmic truths, just using a different language. Take this verse, for instance. The source presents it as a spiritual description of that fundamental universe-holding force. This idea of an unseen power keeping the entire cosmos in a perfect, stable balance, well, that's interpreted as an echo of the very role that gravity plays in our physical models. Now, let's jump back to Einstein's big idea for a second. In a universe where space and time themselves are bent by mass, there's no such thing as a perfectly straight line. Every path anything takes, whether it's a planet or a beam of light, is fundamentally curved. And this is where the source makes another really cool connection. It points out that the specific Arabic word used here for ascend is ta'ruj, and that word doesn't mean to go up in a straight line. It implies a curved, a winding, or a spiral path. This linguistic detail is presented as being just remarkably in tune with our modern scientific understanding of motion through a curved universe. So after this incredible cosmic journey, the source material brings it all back home, making a really powerful argument about our own future. It says that this relentless quest for knowledge isn't just about curiosity. It's the absolute key to the survival and progress of our civilization. The source argues that our future is going to be defined by breakthroughs in 4 key areas: mastering gravity for travel between the stars, advancing genetics to shape life itself, developing cryogenics for long-duration journeys, and unlocking new forms of energy. The suggestion is that the nations that lead in these fields will lead the world. And this all builds up to a pretty passionate call to action. The point is that real progress, the kind that moves humanity forward, isn't born from rigid political or economic systems. It comes from intellectual freedom, from investing in research, and from empowering our smartest minds to just discover. And this final quote from the source really nails that sense of urgency. The vessel heading out tomorrow, that's the future. And the price of a ticket is a real, deep commitment to science and knowledge. So we're left with this one last huge question to think about. As we uncover these beautiful, elegant laws that govern everything from the smallest atom to the largest galaxy, are we just mapping out the mechanics of a random universe? Or are we, maybe, getting a peek at a much deeper, more intentional design? It's something to ponder. Thanks for joining me for this one.